This image of a liquid metal slug and its clear atomic trail shows the breakthrough in action. When dissolved in a liquid metal core, certain metals leave behind this clear layer of their oxide, which is no thicker than a few atoms and can be peeled away by touching or rolling. Credit RMIT University. Researchers from RMIT University in Melbourne, Australia, have used liquid metal to create two-dimensional materials no thicker than a few atoms that have never before been seen in nature. The incredible breakthrough will not only revolutionize the way we do chemistry but could be applied to enhance data storage and make faster electronics. The once-in-a-decade discovery has been published in Science. The researchers dissolve metals in liquid metal to create very thin oxide layers, which previously did not exist as layered structures and which are easily peeled away. Once extracted, these oxide layers can be used as transistor components in modern electronics. The thinner the oxide layer, the faster the electronics are. Thinner oxide layers also mean the electronics need less power. Among other things, oxide layers are used to make the touch screens on smartphones. The research is led by Professor Kourosh Kalantarzada and Dr. Torben Danica from RMIT's School of Engineering, who with students have been experimenting with the method for the last 18 months. When you write with a pencil, the graphite leaves very thin flakes called graphene, that can be easily extracted because they are naturally occurring layered structures, said Danica. But what happens if these materials don't exist naturally? The video will load shortly. Video showing the novel behavior of liquid metal, part of research by RMIT University in Melbourne, Australia, that is set to revolutionize the way we do chemistry. Credit RMIT University. Here we found an extraordinary, yet very simple method to create atomically thin flakes of materials that don't naturally exist as layered structures. We use non-toxic alloys of gallium, a metal similar to aluminium, as a reaction medium to cover the surface of the liquid metal with atomically thin oxide layers of the added metal rather than the naturally occurring gallium oxide. This oxide layer can then be exfoliated by simply touching the liquid metal with a smooth surface. Larger quantities of these atomically thin layers can be produced by injecting air into the liquid metal, in a process that is similar to frothing milk when making a cappuccino. It's a process so cheap and simple that it could be done on a kitchen stove by a non-scientist. I could give these instructions to my mum, and she would be able to do this at home, Danica said. Metal droplets leave no thin layer of oxide skin on the surface, if this oxide skin is dissolved in an alkali base or acid. Credit RMIT University. Professor Kourosh Kalantarzada said that the discovery now places previously unseen thin oxide materials into everyday reach, with profound implications for future technologies. We predict that the developed technology applies to approximately on a third of the periodic table. Many of these atomically thin oxides are semiconducting or dielectric materials. Semiconducting and dielectric components are the foundation of today's electronic and optical devices. Working with atomically thin components is expected to lead to better, more energy-efficient electronics. This technological capability has never been accessible before. The breakthrough could also be applied to catalysis, the basis of the modern chemical industry, reshaping how we make all chemical products including medicines, fertilizers and plastics. Explore further. Liquid metal nanoprinting set to revolutionize electronics. More information. A liquid metal reaction environment for the room temperature. Synthesis of atomically thin metal oxides. Science 2017. Science.sciencemag.org. Gidoi, 1126. Science.rr 4249. Journal reference. Science provided by RMIT University.